Welcome back, Geometry Thinkers. Today's TEK is TEK G2B. It's derive and use the distance, slope, and midpoint formulas to verify geometric relationships, including congruence of segments and parallelism or perpendicularity of parts of lines. Now, today's video covers simplifying square roots, and our learning objective is to simplify square roots. And you will know you have mastered this objective when you can simplify a square root such that no perfect squares remain inside the square root symbol. Step by step, skill by skill, you can do this. Let's turn practice into power. It's important for us to clarify what it means to simplify a square root. And what that means is that we are rewriting the square root so that no perfect square factors remain inside the square root symbol. But it also means, too, that there are no square roots in the denominator. We will get to that later. However, I want to focus on no perfect squares factors remain inside the root. So the best way to do this is to look at an example. So we see in front of us the square root of 20. And I want to simplify that, or at least see if I can simplify that. So notice that I drew a yellow box around step 1, okay? That's the initial problem that we're given. Step 2, however, is we're going to take this 20, and what we're going to do is we're going to break that 20 down into its prime factors. So I'm literally going to take 20 and I'm going to say, what times what gives me 20? 4 times 5. I know that 5 is a prime number, so I draw a line under it. I know that I can factor 4 into 2 times 2, and 2 is a prime number. So I have now completely factored my 20 into prime factors. So I'm going to take all of these factors that have lines under them, and I'm going to place them up here in a row. And I'm going to put them in numerical order from the least to the greatest. So I have a 2, a 2, and a 5. A 2, a 2, and a 5. My next step, and that's what this green circle is about, my next step is to group all the pairs together. I have 2 2s, so I'm going to circle those 2 2s. I have no more pairs. The only number that's left is this 5 over here. So now what I'm going to do is I'm going to multiply all the numbers that I have circled, and I'm going to place them as my first number right here. And then I'm going to take all the remaining numbers that aren't circled, I'm going to multiply them together, and that becomes my second number. So I'm basically going to take these numbers here and turn them into 2 factors. My third step is to basically rewrite the problem. I'm looking for the square root of 20, and I'm going to take this 4 times 5 because I know that 4 times 5 is 20, and I'm going to place it under the square root. So I have the square root of 20 is now equal to the square root of 4 times 5. When you're taking the square root of things that are being multiplied, you can break them up and you can put them under their own square root symbols. So I can take this 4 and make it the square root of 4, and then I can take this 5 and make it the square root of 5. So now this has turned into the square root of 4 times the square root of 5. What makes this really nice is the first number is always going to be a perfect square root. So I know that 4 is equal to 2 times 2. And so the square root of 4 is going to be 2. So this simplifies down into 2 times the square root of 5. So now I know that the square root of 20 is equal to 2 times the square root of 5. This would be considered your accurate answer. And when you would take your calculator and plug in the square root of 20 and get a long number, that would be your approximate value. So 2 times the square root of 5 is the accurate answer for the square root of 20. Let's look at another example where the number is a lot larger. So here we have the square root of 75,600. Now, don't let that scare you because we're going to follow that same process. It's just a bigger number. And so I take my 75,600 and I want to break it into its prime factors. So in order to do that, I do a factor tree. I know that 75,600 is going to be equal to 756 times 100. I'm going to focus on that 100 and I'm going to break 100 into 2 times 50. 2 is a prime number, I underline it, and then I'm going to focus on the 50. I know that 50 is 5 times 10, and 5 is a prime number. So I can break 10 down into 2 times 5, and I get 2 prime numbers. I cannot break 100 down to anything lower than 2 times 2 times 5 times 5. Now I'm going to focus on the 756. So looking at this, I just took a wild hunch, I guess, and I said, I wonder if 4 can go in there evenly. I know 2 can, but let me just see if 4 can. And 4 worked. 4 times 189 gives me 756. Both of these are composite numbers. They are not prime numbers. So what I can do is I'm going to take that 4 and I'm going to break it down to its prime factors, 2 times 2, and then I just have to focus on this 189. I know that 189 can be broken down into 63 times 3. 3 is a prime number, which then just leaves me with the 63, which is 7 times 9. I know 7 is a prime number, and I know I can break 9 down into 3 times 3. Now that I have all my prime factors, what I did was underline them as I went through and constructed the factor tree. I'm going to take these numbers and I'm actually going to place them in numerical order up here, saying that 75,600 is going to be 2 times 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5 times 7. Now, notice that all of these numbers are represented up here. My next task is just to circle the pairs. I have 2 2s, I have another 2 2s, I have a 2 3s, that 3 is by itself, so I'm going to skip over, and I have 2 5s. The 7 by itself, too. So I'm going to take each one of these, and I'm going to multiply all of it together, and that's going to give me 3,600. So 2 times 2 times 2 times 2 times 3 times 3 times 5 times 5 is 3,600. I'm taking the 3 and the 7, which are left that don't have pairs, I multiply them together, and I get 21. So I know that 75,600 is really 3,600 times 21. So with this brings me to my next step. I'm going to take that 3,621 and I'm going to say the square root of 75,600 is equal to the square root of 3,600 times 21. Notice what's underneath the square root symbol is equal. 75,600 equals 3,600 times 21. Knowing our rules for square roots, we know that if we have factors underneath the square root symbol, we can break those factors up into individual square root forms or square root symbols. So I can take this 3,600 and I can put it under its own square root. I can take the 21 and put it under its own square root. So doing that, I end up with the square root of 3,600 times the square root of 21. 3,600 is a perfect square. That is 60 times 60. So I know that the square root of 3,600 is 60, but I cannot break up the square root of 21 into anything lower. So it just transfers down to be the square root of 21. So the final answer for this problem would be the square root of 75,600 is equal to 60 times the square root of 21. This is how we simplify a square root. Now it is your turn to practice the same skill. The instructions read, simplify the following square root, the square root of 627,200. Remember, you need to show all of your work in your notebook, and you must also write your answers and boxing in your final answer. I should be able to see what's going on inside your head just by looking at your work. If you have any issues or you have any questions, please ask. You may check your answers on the next slide. Now please pause the video and complete your work. Here's the answer to our problem. Please pause the video and check your answer. When you are finished, press play to continue. This is it for today's video. If you are struggling, please ask me or your classmates questions. You can even ask AI if you don't want to ask another person because it can explain how to solve problems as well. Step by step, skill by skill, we are turning practice into power. I know you can do this. Have a great day.